Hello, everybody. I'm going to solve question 54 for algebra section of the course Math1151 at UNSW. This is an applications of to the real life situations of the linear system of equations. Here is the problem. So we have some certain species of animals lives at most 3 years. 50% of the 0-1 years old survive to be 1-2 years old. 25% of 1-2 years old survive to be the 2-3 years old. Each female 1-2 year old produces 4 female offspring in a year. Each 2-3 year old female produces 3 female offspring in a year. If there exist 1,000 female in each age group initially, how many in each age group are there after 1, 2, 3, 4, 5, and 10 years? And we would if the total number is increasing, divide the state vector for year k by the total number of the animals in year k, and to get a vector of the proportions of each age in that year. Investigate the proportion as k goes to infinity, the yearly increase in the total number of animals. So this is the question. So far, what we understood in the questions, what is the situation, is that we have 3 different groups, 0-1 group, 1-2 groups, and 2-3 groups. And we have for each year, the situation changes for each of the group. So it is a recursive equations that we need to think about it for the setting up. So the first thing that we would like to do is all this life situation implement into a mathematical way or equations from that given knowledge, right? We have some given situation here, and we would like to write it down this in terms of the mathematical equations. And we know that we have 3 different groups, and each group is changing situations for each k. And of course, what is happening this year, depending on what happened in the last year. So it's a recursive formula for each k. We have the k plus 1. K is the years, and k plus 1 is the next year, k plus 2, 2 years later, and so on. How we can write it down? First, we would like to write it down our variables. What kind of variables did we need to use, or functions or equations? In this case, we have 3 groups, and each of these groups, depending on the k, depending on the year. So that's what we do here. K is a number of the years. X1 is the number of the animals of the age 0-1 in year k. X2k denote the number of the animals of age 1-2 group in the year k. And X3k is the number of the animals of the age 2-3 group in the year k. So here it is given to us that 50% of the 0-1 year old survive to be 1-2 years old. This means that 0.5 is a half, 50% of the first year 0-1, that's X1k, that's the first group, survive to be, which will be what will happen to the next year, X2k plus 1. So these sentences can be written mathematically in this fashion under this assumption. Similarly, 25% 1-2 year old survive to be 2-3 years old, means that 0.25 times x2k, this is the second x2k, right? This is the second group that we were thinking, the 1-2 year old group. Survive means what's going to happen next, to be in the group 2-3. That is x3k plus 1. We have 2 equations so far. We also have each female 1-2 year old produce 4 females. Each 2-3 year old female produce 3 females. So each these 2 groups will give us one formula, right? That is x1 k plus 1. That is the x1 is the 1 years of the group in newborns, the newborns in the next year, depending on 4 times to the 1-year-old, which is X2K, and the 3 times, 3 females, 3 times to the 3 years old. So these sentences here can be written as mathematically, it's just sentences. So we have a linear system of equation. We have 3 equations. We have 3 unknown vectors, recursive formulas, and initially all of them has 1000. What we have basically, so these equations can be written as, these are the 3 equations. These equations, that's what we got, can be written as a linear system of equations. If we say this, if we looked at this one as a vector, if we looked at the x1, x2, x3 as a vector, then these equations will be x vector xk plus 1 vector is equal to the coefficient matrix, which is 0, 0, 0, 4, 0, 0, 3. I think that, I mean, it's 4, 3. There's an error here. This is 4. This is 4. This is 3. This is x3. I don't know where that's coming from. Okay, and then the coefficient matrix, this one is 0.5. I have 0, 0 here. I have 0 here, and the coefficient of x2 is 0.25, and the coefficient of x3 in the last equation is 0. So the vector here, x1, x2, x3, and k's will be on the right-hand side. If I multiply this column with this row, I will obtain this vector. If I multiply this row with this column, I will obtain the second equation. If I multiply this row with this column, I will obtain the third equation. So this system of equations can be written in this format as the coefficient matrix and the vectors. It says that initial vector, when k is equal to 0 k's, everything is 1000. Each group has 1000 animals in them. So, okay, then we can calculate the first year for each group, just multiplying the coefficient matrix with this initial matrix will give us the values for the first year. And multiply this matrix with the initial ones, we will obtain this vector. Now, using this vector, we can calculate what's happening second year, just multiplying the coefficient matrix with the second year vector, and we will obtain this vector. And similarly, third year, fourth year, fifth year. And for the 10th year, you need to use MATLAB is the best way to use some kind of a computer aid. Even you can use an Excel, that will do. Whatever you can. I can't see any point to calculate this one 10 times. So just write it down. I'm just writing down the answer here. This was the first part. So we calculate the first 5 years and the 10 years position, just the recursively. So in order to calculate this one, you need to do it really the 9 times to get that. Use some computer aid to do so. Second part of the question asks us to calculate this quantity, which means this is the vector in each k, and this means that you are adding all these components of the vector, right? For example, for x1, and this is the x1 vector, and the summing up all the components means that the summing up all this one, and this one, that will give you 7,750. And these y vectors will be just a division of this total each component. So I'm dividing this 7,000 divided this one, I will get 0.9. 500 divided by 7,750, I will get 0.07. 250 divided by 7,750, I will get 0.03. If I mean, this vector is just really the representation in terms of percentage, actually. If you add all of those percentages, it will be 1, right? And this is because of that's what we are doing. We are adding all the things up and dividing all these components. Basically, you're making the whole proportions. So these are the proportions of each group, how it grows. So I'm not going to do these calculations one by one. I've done it by using the Excel very quickly. So this is the k is equal to 0 vector, k is equal to 1 vector, k is equal to 5, k is equal to 10 vectors. And I add those quantities up, and this is the addition. And then I divide each of these by this number. This is how I get the YKs. YK vectors are here for k is equal to 0, for k is equal to 1, and so on. And as you realize that if you add all these things up, you will get 1, because this is just a proportion. Your YKYs are the proportions of each group at that time for each k. And then here, what I've done, I've looked at the yearly total increase. That means I've done, this is the increased amount. If I subtract this amount, I will find out the increased amount. So this is what I've done here. This minus this, I found the increased amount. So previously it was 3,000. Dividing by 3,000, that will give me the increased, how far it increased is a proportion. Then I calculate all of those for each years and take the average of these years, and you will get 1.5. So yearly increase in total as an average is 1.5. This means that an average is 1.5 increase when k goes to the infinity. Yeah, I think this is a really nice example as an applications of the linear system of equations in a daily life situation. So that's all for this question. Thank you very much for listening.